Well, there we go. So we are recording now. Everyone can see my screen. Are we okay with that? So again, if you have questions, type them there in the chat. I'll try to keep an eye on things. Today we are going to cover two different topics. We are going to talk about population. This is kind of the foundational lesson on population. And then we are going to talk about how to measure longitude. So I was going to try to demonstrate how to measure latitude using Polaris, using the stars. But I couldn't because we had pretty much a whole week of cloud cover here in Utah. So that is one of the problems with all these celestial navigation issues, is that sometimes you just are out of luck, you know. So let's get onto this. So first, a discussion here about population. This is an interesting talk that President Romney gave in the 1973 conference. This is Marion G. Romney. He was one of the counselors in the first presidency during the years that I was growing up. And he was the first counselor in the first presidency for many, many years. And he shared this experience, okay? So you also had the rain cloud cover there in La Paz. Okay, so that's the rainy season. So we are in the cold season here in Utah. So this is what President Romney shared a story. Recently, my secretary put on my desk an article which reported an experiment carried on by the National Institute of Mental Health. Okay, and this is the experiment. A tiny Eden for mice was built. In it was placed everything that could be included in a mouse's dream of paradise. Food, housing supplies, everything was there in abundance. In it were placed 4 pairs of mice, so 8 mice total. There was room for 4,000 mice. Every 55 days the population doubled. That is how fast mice reproduce. But when there were a little over 600 mice, things began happening. Not only did the population fall off, but big problems arose in the mouse society. The mice were becoming lazy. Many appeared greatly distressed, some utterly frustrated. Their behavior became quite unpredictable. The making of nests dropped off. Some of the mice began to eat each other. The planned mouse population never did climb to 4,000. They had reached slightly more than half that figure when reproduction came to a complete halt. The mouse society turned into an emotional mob. The population of Mouse Eden has now dropped to a little more than 600. No new baby mice are being born. The mouse society is doomed, and not a mouse shows any interest in saving his dying paradise. Okay. What do you think that happened? Annika says, sounds a little like our human society, unfortunately. Yeah. How is that similar to our human society, and what do you think that happened here in this mouse Eden? Why did the population stall? Why did the mice become lazy? They had everything handed to them and they became lazy. Okay, they got lazy. That's Annika's comment. Yeah.
They didn't have enough work to do.
They didn't have enough work to do. A great comment, Nathan. Yes, they didn't have any work to do. They had everything that they needed available to them. Okay. So it is interesting that you see the effects of having everything basically provided for. Okay. This reminds me of Lehi's words when he said there is it is what how does that go in what is it, Second Nephi 2:11? There must needs be an opposition in all things. Okay. So when we don't have an opposition, bad things happen. It's not just that it is necessary to have opposition, it is actually essential to have opposition, to have work. Okay. So President Romney says idleness is just as devastating to men as it is to mice. Okay. So these are some of the things to think about, okay, as we are going to talk now about population here, okay. So this is the Buckeye Stadium, all right, let me see. This is the Ohio State University Stadium. I think that it houses 70,000 people, okay. So if you were to have 1,000 of these stadiums, you would have about the world population. Okay, so let me see if that is correct. What is that? So we have.
You are cutting out.
So let's see. So
you are cutting out.
Sorry, I was cutting out. So if we have, oh, so the stadium houses 100,000 people. Okay, so if you have 10, that would be 1 million people. And so if we were to have 70,000 of these stadiums, that would be the population of the world. Okay, so, you know, when you think about it, you can put it kind of in perspective of how much the population of the world is. This is the kind of a clock of the current world population, all right, and it keeps counting, and these are of course kind of based on estimates, but that is kind of how it goes. Oh, okay, sorry about, yeah, I didn't send the email, Haley, because I was late. I had to reset the password here, you know, it was a mess, and so I didn't have time to send the email. I apologize for that. Thank you for trying and coming. Okay, I hope that no other people are missing that because of that. So this is the current world population, and we can see how it is increasing. All right. Let's see. And so this chart now here shows how the world population behaved basically through the history of the world, all right? So we don't know exactly how the world population was, but we can assume that it increased pretty healthily, you know, from the time of Adam and Eve all the way to the time of Noah. And then, of course, there was a drastic decline at the time of Noah because of the flood. And then, what do you see in the curve of the world population? How do you see that happening? Okay. Okay. Oh, so yeah, we have the same number for every class, but they have a different class number. The pin, it has a different number. I don't know if that is kind of smart. We probably should try to have one for the same, because we are never on this, you know, at the same time in the classroom. Okay, so I'll try to talk with the teachers on that. Okay, so can you notice when was the population? Okay, so the population, it's kind of goes up and down. Okay, it goes It was actually up, then down, then up again, and then further up. All right. Okay. When is this time when the population of the world just starts kind of taking off like crazy?
When the gospel was restored.
When they got, sorry, what?
When the gospel was restored.
Yes, it was really about the time of the restoration of the gospel. Yeah, yeah. So, and it is really in the early 1800s that is when the world population really started to take off. Okay, and so today we are going to talk about what were some of the causes for that. One of the causes was that people were able to have larger families. Okay, have you ever heard about Florence Nightingale?
Yeah.
Who was Florence Nightingale?
Wasn't she a doctor? She was a nurse.
She was a nurse, yes. She was a nurse, and she was one of the first female nurses, okay, that went to war, actually. So she went to the Crimean War. That was a war between the British Empire and Russia in Crimea. And one of the things that she discovered there was that more soldiers were dying in the hospital than in the battlefield. So the battlefield was healthier than the hospital. Okay. If you got wounded in the battlefield, chances are you were going to probably die in the hospital. All right. One of the problems was that the hospital, they didn't know, but the hospital was built on top of an open sewer. All right. And yeah, yucky. And at that time, they didn't know anything about bacteria and viruses and infections. And so Florence Nightingale and some of the other doctors around that time, they actually were the ones that discovered the bacteria and the infectious diseases. And they turned really the world by hygiene. They actually relocated the hospital and they started actually to use hygiene, basically washing their hands and things like that. And that made a huge difference in the number of children that survived, not also, of course, the number of soldiers that survived, but also it made a huge difference in the number of children that were able to be born and stay alive. Before that, the families would, have children, but they would die very fast. Okay, and so one of the things that happened was neonatal care. All right, so people are able to take care of children when they are born better, in a cleaner environments, healthier. Vaccination was also that started around that time, and that was had a huge influence on the world population. One of the antibiotics were discovered during World War II, and actually many people say that one of the main reasons why the Allies won World War II was because of antibiotics. Penicillin was discovered right before the war, okay, and the soldiers that were wounded were able to recover faster because of penicillin and then being able to go back and keep fighting. Instead, the Germans didn't have antibiotics, and so their wounded took a long more time to recover if they recover. Okay, so there are very many advances in medicine and things that had a huge influence to the world population. Okay, yes, and yeah, it's great that now they have alternatives to penicillin if you're allergic to penicillin. Most of the people that are alive in the world today owe their lives in one way or the other, directly or indirectly, to penicillin or some of the other antibiotics. Okay, so Jens is asking what is the alternative. So there are other antibiotics that are kind of similar to penicillin but do not cause the same allergic reaction. Okay, good questions. So let's see this video here together about the world population. This was something that was produced by NPR, and see how they explain the growth of population.
1,000 years ago, there were only 1/3 of a billion people.
Can you hear okay?
We were multiplying. Now there's 7 billion of us. How did we grow so much so fast? Say this glass is North America. The fuller the glass gets, the more people there are. Water drips in as people are born. Water drips out as people die. Okay, here's the entire world. Now let's go back 1,000 years.
See how little the population
was. Empty. Europe and Africa have less than 100 million people between them. And just like today, most people live in China, India, and the rest of Asia. For centuries, things stay pretty much the same. Births are canceled out by deaths. Women are having lots of babies, but most babies die before they grow up and have families of their own. We don't reach 1 billion until 1804.
Notice the time, the year.
But things are changing. Better medicine and better agriculture are starting to slow the leak from the bottom of the glass. People still die, of course, but more babies grow up and have babies of their own. Lots of babies. We've grown from 1 billion to 7 billion, and it only took 200 years. Will we keep going like this? Probably not. The UN says we'll level out at 10 billion by the end of the century. So as we continue to grow from 7 billion, the question is, can the world hold that many people?
What do you think is the answer to that question? Can the world hold that many people? Haley, you say yes?
Yes.
Yes, Nathan says yes. Rachel says maybe. Emmeline also says yes. Okay, Abigail, you say, I think God will find a way for it. Yes, Jens also. Yes, you know, the scriptures tell us that the earth is full and has plenty and in abundance. Okay. So in fact, really, one of the things that I love about studying geography is to see how amazing really this world is that Heavenly Father created for us to really accommodate so many people, you know, and to provide for everyone, okay? There is, of course, hunger in the world and other problems, but those are things that we could actually really solve, all right? The problem, for example, of world hunger is not an issue of lack of food or resources, it's a problem of distribution, really, okay? Yeah, Heavenly Father wouldn't put us down here if there wasn't enough room. That's correct, yeah. And so that is one of the things that is important for us to know and understand. Okay, let me close a couple of these tabs. So here now we are going to talk about briefly about some of the, is that better now? It's kind of lagging. Let me stop the webcam and see if that is better. Okay. So hopefully that will be a little better. This is still okay. That was weird. Okay, I hope that this is all right now. So let's see what are some of the reasons why populations go down, all right? So let's see, Annika, you have a comment here. My science teacher in Ukraine was adamant that nobody should have kids anymore because of overpopulation. I think we had a bit of a disagreement nearly every class. I know we will have room if we are supposed to. Besides, we are commanded to multiply and replenish the earth. That's absolutely right. Yes. The people that actually think, that the population is overcrowding the earth are actually, pretty wrong. Very wrong, really. In Ukraine, actually, they are having a big problem because they are not having enough people really to reproduce. So that is actually a big problem in a lot of places in Europe. Okay, yeah. So there are some natural disasters that actually cause big problems for people. For example, flooding, or weather disasters like cyclones. Last year we had a huge typhoon in the Philippines. Okay. And she was an American. Yeah, that happens too. A lot of people here in America have that mentality. Famine is certainly one big problem. When there are droughts and things like that. Again, the problem is not that there's not enough food, but that the distribution of food suffers. Sometimes, of course, earthquakes also cause problems with population. So those are some of the natural disasters. Here in Wikipedia, we have kind of a grimy, not very happy page, okay, talking about the list of natural disasters by death toll, okay? So the 10 worst natural disasters, all right? And so, of course, these are the ones that we know of, all right, that have been recorded, and we know kind of an estimate on of what happened. So in 1931, it seems that in China there were severe floods during July of August. Between 1 million to 4 million people, okay, died. And another flood, earthquakes, cyclones, all right, so we have these ones in 1970, pretty recent. Calcutta in 1737, all right. I remember this one, the Indian Ocean earthquake and tsunami. Yes?
Rodney has a question.
Go ahead.
What was going on? I couldn't get to here. I was really trying and it wouldn't let me come.
Oh, were you waiting for my email, or were you not able to get in?
I came to my email.
Uh-huh.
So I tried the science GoToMeeting address, got off that. Went to geography GoToMeeting. Okay, it didn't work. It said waiting for organizer, meaning you weren't there.
Oh, yeah. At the beginning of the class, I had a hard time logging in because GoToMeeting was asking me to change the password, and I actually used the school's account. So anyways, I got here kind of late at 2:07.
Yeah, I was trying to get on at 12:10. So. So
yeah, probably it was still around that time. So anyways, I'm glad that you are here. Okay.
But I'm here.
That's the important part. Yeah. So we are talking about population, and here are some of the things that affect population, some of the natural disasters that affect population. I remember this one in 2004. There was a tsunami, an earthquake and a tsunami almost immediately after in Indonesia. And it affected the island of Sumatra in Indonesia and then affected the island of Sri Lanka, and many people died, okay, out of that. So that happens. That is, another factor that affects world population is war. Here we have also in Wikipedia the table with the casualties of World War II by country. Okay, so you can see that lots of countries were really affected. Okay, some, a lot. It's interesting to see, for me it was interesting to see how much China, how many people died in China during World War II. We almost never hear much about it. The Japanese invaded China, and it was quite brutal, really. So Germany, of course, okay, lost a lot of people. Japan, probably about half of the casualties that they had in Germany, all right? And then certainly several other countries had also participation during World War II. See the number of casualties of the Soviet Union, okay, of Russia. So they probably lost the largest number, really, of people. And for the United States, this was also one of the worst wars, really. Okay, so wars are also a big factor on how. So we were talking about things that promote the growth of population. We were talking about hygiene and hospital care, medicine, antibiotics, vaccination. Those are things that promote the growth of population. And then these are some of the things that cut population off, natural disasters, wars, epidemics. Okay, so here we have a list of different plagues and epidemics, and see the list of those. It goes on and on and on. Of course, that the closer we get to these times, the more are listed, and it's not because there's more, okay, of these, is that we are keeping track and keeping record of them better, really. Okay, so that is, but they are still considered epidemics. Okay, this is a problem. This is the total fertility rate, so meaning children per woman in Europe. Okay, and it's going from 1970 to 2002. So what is happening with the European countries in their fertility rate? What can you see here in this chart?
It's decreasing.
It is decreasing. The rate is declining. They aren't having as many children. It is interesting that really, for analysis really of world population, these rates are plummeting, frankly. This line here at 2.1, 2.2, okay, that is called the replacement rate. So basically, if you have a couple of people, you have a family, all right, if they have on average 2.2 children, then the population of that country is going to be replaced and remain stable, all right? It has to be a little bit more than 2 because sometimes, because of natural causes, death, war, pestilence, and so on, people die earlier, before they can reproduce themselves, okay? And so the replacement rate is considered to be 2.1, 2.2, okay? When a country's fertility rate goes below this line, the replacement rate, then the population is going to start decreasing. When the fertility rate goes below 1.5, okay, or I think that is 1.7 actually, when the fertility rate goes below there, the population is actually going to be doomed. Okay, so in a couple of generations, unless something else happens, that country's population is going to be wiped out. Okay, so of course other people will move in and live in that place, but that population will pretty much disappear. All right, you see the curve here for Spain. All right, it was at around close to 3. Okay, now they are below 1.4, probably around 1.3. So in Spain, you have that most families are either having one child or no children at all. Okay, and the Spanish people are literally disappearing. Okay, so that is a really, really sad state of affairs. As a church, we know that that is not God's plan. Okay, we know that Heavenly Father wants us to reproduce and replenish, multiply and replenish the earth. Okay, and so we need to take that counsel carefully. So hey, look up where most of the children are being born in the world. So which are the populations that are actually thriving now? Okay, so those are the populations that are going to literally inherit the earth. Okay, in a couple of generations, those that multiply are the ones that are going to be there. Really, so you have to be careful. Okay, I have here in the lesson there's a clip to Elder Anderson on children. This is a very cute video, and I encourage you to watch it. And it talks really about how important it is for us to have families and to embrace that, to decide to have families. Okay. So God has provided this world really with everything that we need for us to have families. And that commandment of multiplying and replenishing the earth remains enforced. Okay. So Annika says, my biggest argument against my science teacher, there was an American science teacher in Ukraine, was exactly this. If people, let's see, if people don't have kids, countries will be gone. No people, no culture, no government, nothing. She still didn't agree with me. Very short-sighted, and interesting that they wouldn't understand that. So most of the children are being born in Africa. Okay, Asia is also a large contributed for that. So Rachel, you say Muslim populations. The Muslim populations are really rocketing. Okay, so and in fact, most of the European countries are, if you wish, going to be pretty much taking over unless the local populations wake up and have families. They are going to be taken over by the Muslim populations that immigrate to the European countries. Okay, there's no question about that. Yeah, go ahead.
I was reading this article yesterday in the national edition of the Deseret News, and it was about in China how the population has become imbalanced, girls to boys, because of the law about only having one child. So there's so many people who have all had boys, and there's not enough girls. So there's all these boys sitting around in China. So that's So then they're out looking for women in other countries and stealing women from other countries. And then they have to, in order to have more than one child, you have to pay a whole bunch of money. And I was reading it and I was like, oh my goodness, this is such a nightmare.
It is. Yeah. It is a huge, huge problem for China. Okay, it's a problem of their own creation. They put in that policy in place of a one child policy in order to stop really the growth of the population, and culturally most families want to have a boy in order to continue the family name, and so they either abort girls or they literally kill them after birth, and so there is a huge imbalance there in China. All these things are extremely sad, and Heavenly Father will not hold us guiltless unless we change. Okay, so this is, a very, very bad thing. Okay, it has all sorts of bad implications, really. Yeah. Okay, so I would like you to listen to this video of Elder Jensen and think about, the importance of families and frankly how grateful I am of having, a faith, a culture that promotes large families. Okay, so in our LDS culture, we actually not only welcome but promote still having large families, and it's such a joy, really. I have 8 children, and I tell you, I love each one of them, and I couldn't imagine having a smaller family, really. So, yeah. So, yeah, Rachel, you also come from a family of 8. Excellent. So, yeah, I would like now to so they couldn't even go back to China because they had other children. That is awful, really. So I would like now to switch gears for a little while for the remainder of the time, and I put together a presentation here about how to measure longitude. Okay, so see, you are all coming from pretty large families. That is awesome. Now I want to tell you something that is very important. There are some families that cannot have children. Okay, so we almost always need to be careful never to judge anyone about, whether they have children or not have children and so on. So I know several families, several friends of mine that are married, but they cannot have children. They would love to, okay, or they had one and then they couldn't have any more. All right, so we always need to be sensitive because these families usually they would probably love to have more. Okay, sometimes adoption is a great alternative. In my mind, it is always a great alternative. Sometimes for personal reasons, they don't consider adoption. So we always need to be careful because, like the leaders of the church say, that is always a prayerful and private decision of the couple. Okay. So again, let's switch some gears here, and we are going to look about measuring longitude. All right, hey, Abigail, there one vote more for adoption. So you are adopted, excellent. I'm all for that. Yeah. So I think that is awesome. Have you any of you tried to measure longitude using some type of celestial method? Okay. Let's go. Yes?
No, I said no, I haven't.
Okay. So let's review a little bit. So longitude denotes a location of a place on Earth, east or west, or of the prime meridian. So if this is the prime meridian, okay, let's do that here. Okay, this one is the prime meridian. All right, 0 of longitude. So if you measure west, okay, or you measure east, that is the position in degrees, okay, around that prime meridian. So points with the same longitude line in lines running from the North Pole to the South Pole called meridians. So anywhere, so the latitude is this measure, but anywhere along this part, it would be the measure of longitude, okay? So that is kind of a review. Here we have another picture that we had already seen of that. So we have the prime meridian, and it divides the Earth basically in two halves, the western hemisphere and the eastern hemisphere. Okay, so you have from 0 to 180 west, and from 0 to 180 degrees east of longitude.
Does anyone else see that the planet is like uneven in that picture?
Oh, yeah. It is. I don't know why. I borrow it. Okay, so Annika, I measured something in the 5th grade, but I don't remember what it was. It was possibly that it was longitude. Okay, so let's see if this helps out. So what are the things that we need to measure longitude? Okay, so the first thing that we need is to have the precise time when a celestial event will happen over the prime meridian. Okay, so we need to know that. We need to know when something is going to happen over the prime meridian. So like the sunrise or at noontime, the sun zenith, okay, sunset, moonrise, moonset, or when some planet like Venus or a star will rise or set, okay. And nowadays we don't do this very often, but people were used to do this all the time, especially navigators if you were in the ocean. And these events were recorded in almanacs. And I have here a link to an almanac. Let me see. This is the page of the almanac. I tried to have the webcam on, but it was kind of slowing down the connection. So this is a page of an almanac. So this was an almanac published in 2002. And as you can see, okay, I'm going to kind of go closer here. It has one page for 3 days, May 10th, 11th, and 12th. And then it has for each day, each hour of each day, the positions of different stars. And then in this page, it has the positions and the timing of events for the sun, the moon, okay? And then here it has like sunrise and moonrise, moonset, okay? Sunset here. And you notice here that some of the events, the timing will depend on the latitude, okay? So again, in the sunrise, for example, is different depending on your latitude for that particular day, okay? So these almanacs were actually very useful for people that needed to do navigation. Okay, so we are going to use something like that. So the second thing that you need is a clock that is following the prime meridian time. Okay, the Greenwich, okay, the new name that people have come up with that is called the UTC time. So it's the Universal Time Coordinated. Okay, so that UTC or UT is a prime meridian time. All right. I couldn't find an online almanac online for the current events. I could find something kind of similar to that, all right? I couldn't find the chart, so that the latest chart that was published in that website was for the year 2002, all right? They do have some almanacs, okay, that just give you on the web now different events and everything, but they are kind of different, and they are not telling the event at the prime meridian. They now tell you the event at your position. Okay, so it's kind of defeating the purpose. You need to know your position. So, all right. So yeah, we are getting too smart here. Okay, but I'm trying to teach you the old-fashioned way. All right. So we need the event, the clock, and then you need to know that 1 degree of longitude equals 4 minutes of time. Okay, so imagine if you have along the Earth, you have 360 degrees, if you go all the way around the Earth, and there are 1,440 minutes in the day. So how many minutes are for 1 degree? Okay, so so you put that. This is proportionality. This is one of those math skills that I told you is very, very useful. And so you multiply, you do the cross products, and you multiply the ones that are there, and you divide by the one that is with the x, okay, along the cross. Okay, so 1,440 times 1,440, divided 360 gives me 4 minutes. So 1 degree is 4 minutes. So what that means is that if the sun rises over the prime meridian, let's say at 6 o'clock, okay, if I am 1 degree west of the prime meridian, the sun is going to rise at 6:04. Okay, so that is why this is important. All right, so these are the 3 things that you need to have and to know. Okay, so for some events also you will need to know your latitude, like I was telling you. Okay, like in the sun and moon events, they are dependent on your latitude also. Okay, so now let's see an example. So for example, you measure your latitude to be 40 degrees north. All right, the almanac says that on this day, UTC sunrise at 40 degrees north is 4:49. All right, so if we go back to the almanac, okay, and we see, there we go. Okay, so we see the almanac, 40 degrees right here. All right, the sunrise 4:49. Okay. So this is when it should happen over the prime meridian, okay? So that is how you read that. So wherever you are, let's suppose that you're in the middle of the ocean, and so you know that the sun is going to rise early. So you wake up early to see the sunrise, and it feels like 4:30 in the morning, and you wait until the sun rises. As soon as the sun rises, you look at your clock, and the clock shows that it's 8:19 UTC. So instead of, coming up at this time, it came later. Okay, why is that? Well, it's not that the event didn't happen. The event did happen at 4:49 over the prime meridian. What it means is that you are not on the prime meridian, okay? And so let's see what you do next. So you subtract the 2 times, okay? And you find that the event happened 3 hours and 30 minutes after it was supposed to. That is 210 minutes, okay? So if we said that 4 minutes is 1 degree, 210 minutes, again, we do the cross products, and we found out now that we are 52 okay, degrees and a half west of the prime meridian. So about 40 degrees latitude. We said that we were 40 degrees latitude, so we would be about there. Okay, 52 and a half degrees west of the prime meridian and 40 degrees latitude. Okay, the Earth rotates this way. Okay, and so the events that happen at the prime meridian, they will happen later on the west. If an event happens earlier than it's supposed to, then it means that you are east of the prime meridian. All right, and so the thing would work exactly the same way. Okay, so that is one example of how to measure longitude. Is that okay? Okay.
Yes. Pablo.
Yes, go ahead.
You on your camera, so you make motions with your hands. We know where you're going.
Okay, I'm trying not to make motions.
You said the Earth moves like this.
Oh, didn't I put an arrow here on the planet?
No arrow. Oh, there it is. I see it.
Okay.
I can't see it. It's really small.
Oh,
okay.
Sorry. Okay, let me make it bigger arrow. Okay, here, huge arrow. Right. Good deal. Good deal. So let me show you what I did here. Okay. So on October 4th, 2014, this was the day of General Conference. Okay, I went to my patio. It was a nice sunny day, and so I said, okay, let's try this. Let's do it. So I made a kind of a sundial. All right, it doesn't need to be of this shape or anything, but I just put some cardboard and put it on the flat. All right, I oriented it with a compass. I don't know if you can see here the compass. And so I tried to orient it north to south, okay, this part. And let's see, you could try to turn on your camera. It might work. So let's try the webcam. Okay, so we are sharing. Can you see me now? Okay, people can see you. They say, okay, so all right, good deal. So what I try to do here is to orient this north to south. I know, all right, that in Utah, in this part of Utah, there is what is called a variation, a magnetic variation of 14 degrees west. So that is why if you look closely here, okay, so the thing doesn't align exactly north. It's about 14 degrees west, okay, in order to align it north to south according to the magnetic variation. All right, so this is pretty much north to south aligned. Okay, that is what I try to do. Then I tape everything so it wouldn't move. And then I had a clock. On my phone, I had a clock that was on UTC time. This was not Utah time. And so I started making dots here and recording the time, the UTC time. This was about, noon, all right, here in Utah. Okay, but UTC time, it was 7:03. All right, when I started the exercise. And so I kept recording the time every 5 minutes and put the points where the shadow was pointing to. Okay? What I should have done is I should have continued recording this all the way, but the problem was that we needed to go to General Conference with my family, so I had to leave. But what I did was I recorded the time, the UTC time, when the shadow was perfectly north to south. Okay? So that indicated to me this is noon at this point in time, at this place in the world. All right? When the shadow is exactly north to south. Does that make sense? All right. So Yeah, so it was a good reason to stop. All my family was leaving, and they were not going to be very happy if I continue with this. So I recorded that, but I stalled enough to get at least here to this point. And so now we get closer there, and so I recorded that the shadow, all right, was pretty much exactly north to south, and I recorded at 7:19, 30 seconds, okay? So that was my measurement of the event. So the sun at noon, in the prime meridian, it should have happened at 12, but in the place where I was, it happened at 7 hours, 7 p.m., 19 minutes, 30 seconds, okay? And so with that, we are going to do our calculations, all right? So if the event was supposed to happen at noon, but it happened at 7:19:30 p.m., where was I, okay? So an event, so if we transfer 7 hours, 19 minutes, 30 seconds into minutes, it was 439.5 minutes later than it happened on the prime meridian. And then we do again our calculation, all right, the cross product, 439.5 times 1 divided 4, that gives me 109.875 degrees west, all right? Remember how we did the transferring from degrees to minutes and seconds. So you have this number, you subtract 109, you end up with 0.875, you multiply that by 60, you get 52.5, okay? And that means, 52 minutes, 30 seconds, okay? So this is the measurement of longitude that I got, okay? What do you think? Is it pretty good, pretty bad? Okay, now we need to verify that, all right? So my measurement was 109.52.30. When I went to Google Earth, okay, I positioned my place, where I was, and my place is actually 111.54.38, okay? So I was 2 degrees, okay, 2 degrees and 2 minutes wrong, pretty much, okay? Not a whole lot, but if we are going to look at errors, this is the distance that I miss, okay? So about 110-mile error. Oops, I exited the presentation. Let me go. Back. Oh, bad. Let's go the other way. Okay, so 110 miles of error. So I was, here in eastern Utah. This is the Utah-Colorado border, the Utah-Wyoming border. So it was about here where I was instead of here. All right, so longitude, remember that last time when I was measuring latitude that my mistake was just 15, 16 miles difference, okay? It was just, a little bit here, the difference in latitude. Longitude is a lot harder to measure accurately, okay? But this is how you would measure longitude with the sun, okay? I missed by 110 miles, okay? Let's see how good you do, all right? So the assignment for this class, I'm going to also make it a 50-point assignment, and I want you to measure longitude from the place where you are using one of these methods. What do you think? Is that okay? Are you up to the challenge? Yeah, I was way off course. Well, that is how...
I was about to say, there's a time I wish that
I was a great mathematician, but I think I'll be okay.
I think that you will be all right. Okay. So I have this presentation. Of course, the video is going to be uploaded in the class, and I have the presentation also uploaded in the lesson. So if you need to review any of the parts and everything, you can do that. Okay.
Mr. Bowley?
Yes,
Are we going to get partners in this class?
I'm not sure. Okay, I actually would like to see how things go with the teams in the science class, frankly.
Okay.
Okay. So before we do too much mess around here. Right. This I really why you say. What do you mean, Rodney, on this? I don't get your...
Don't get your directions this way. Is really what you're saying. But the general idea instead. General area.
The general area. Well, so what happens is really, you know, I had a pretty crude measurement, okay?
So don't get your directions that way.
No, that's right. But imagine if you are in the middle of the ocean. Imagine if you are in the middle of the ocean, 110-mile error is significant. Certainly it is significant, okay? I wouldn't, you know, sleep very, very comfortably on knowing that it could be that off, okay? But at least it gives you a pretty good idea of where you are. All right. And again, if you were to have better, you know, tools and do several measurements, you wouldn't do just one measurement if you are actually depending on this. You would do several of those. Then you would, you know, you would get better at it. Okay. But longitude is difficult.
Is this how they travel, how Mr. Bowditch traveled on the ocean, basically? Is that what you're saying?
Well, so they did similar things. They in that case, they used sextants, okay? Because they had to, you know, in the ocean, you don't have a surface like I was having where you can see the sun, you know, the shadow steady, all right? And so
the box was not moving.
The boat was moving, that's right. And so they had to, most commonly in those times, they would use sunrise or sunset. Okay, because then you knew when the sunrise, okay, or the sunset or the moonrise or the stars, any of those events were easier to observe in a moving ship. Okay. Yeah, the sun noon was more difficult because you would have to measure it with a sextant. Okay, and even that is not that easy. Right.
I actually have a question.
Yes.
Do you recommend doing the sundial method?
Yes, okay, I think that is easier because you know that it would be at noon, okay? What I would actually do differently with the sundial method, if I were to do it again, okay, I would, like I was saying here, I would probably stay longer, you know, and keep measuring, and then I would find what is the point of the shortest shadow. As you can tell, the shadows are you know, getting a little bit shorter, not very much, all right, but the shadow of the sun makes a hyperbola, okay? And so the shortest shadow is really the noon shadow. So you can, if you are going to use this sundial method, keep measuring, okay, don't stop, keep measuring the shadow on the other side, and then find which one is the shortest. You can put a ruler, you know, like around here, and find which one is the one that goes the shortest, and that would give you the time that you would take. Okay, imagine here really if I would have measured this instead of 719, if I would have measured it at 724 or something like that, I would have been pretty much accurate. Okay, I was only 2 degrees off, that means 8 minutes. Okay, so it's not that much really. So that is what I suggest that you do, that you keep measuring and then find which is the shortest shadow.
Okay, makes sense.
Right. Because then you don't need to worry about aligning the sundial north to south. That was my mistake, if you wish. Okay. That kind of was relying too much on my alignment of the sundial. But if you do the shortest shadow, okay, take good pictures and everything, I think that you'll be fine. Okay. Well, time is way past, actually. I apologize for that, but we started kind of late. Let's finish with a word of prayer. Okay. Rodney, would you like to offer a prayer for us?
Yes. Our dear kind Heavenly Father, we're thankful for this day. We're thankful for all the many things Thou hast given us. We're thankful for this opportunity to learn and for possible vulnerability. And please bless us that we may take this opportunity to learn, that we may learn and grow. Please bless that we may be able to study hard and
say the prayer right now.
And Thee.
Okay, amen. Sorry about that. Okay. Well, thank you very much.